Wildfires are becoming more and more prevalent during summer months, and at this moment there are humongous wildfires in Alberta, Canada. Especially the wildfire has come into the township of Jasper. It is wreaking havoc, it is destroying properties, it's destroying people's homes, and it's very unfortunate. With forest fires becoming more and more common, it's very important for us to catch the forest fire at infancy when it's beginning, so it can be contained and it can be prevented from spreading far out. There are solutions out there that kind of try to predict when the forest fire is about to break, but once the fire has broken down, we need solutions that are able to tell that there is a fire that has broken out and notifies the authorities, so it can be contained before it becomes disastrous, before it spreads out beyond the means of control. So looking at the wildfires in Alberta, in Jasper, especially Jasper being a really beautiful town that is being destroyed by these fires, I thought of creating a project to detect wildfires, to be able to use computer vision and AI to detect when the fire breaks out and raise an alarm so that the authorities can act on it very quickly and contain the fire. For this, I used some sort of aerial imagery for this project, but ideally you could use satellite images to capture an area and predict if there is a forest fire or if there is a wildfire breaking out in an area or not. Welcome back to the channel, guys. My name is Dhruv. Today I'm going to show you a model to predict forest fires, to predict wildfires. We'll start with a demo for motivation, and then we'll delve into the technical details. So on the screen here you can see an output video from the model. Here in this video there is a forest fire, and the model output can be seen on the top left of the images, and you can see the predictions for fire and no fire. There is a score, and you can see a high score for fire and low score for no fire, showcasing the model's predictions. On the other side, you can see a video with a scene where there is no wildfire, and the model is able to predict no fire with a high confidence, and this is the testament to the accuracy or the performance of this model. Once we've gotten this motivation, let's delve into the details of how this model has been prepared, how this model has been implemented. So guys, let's go into the details of the model itself, how this has been prepared and what all it entails. So here is the notebook that has been used for training this model and then doing the testing on the model itself. So in this first of all notebook, the first thing we do is we just check for our GPU. So we run the NVIDIA SMI just to see that we are running, that our GPU is correctly running. Here you can see we have a GeForce 4060 with 8 gigs of RAM, and that is good. In this cell we are just basically saving the path to the current directory, because this is a variable we would use further to load data sets and to save our outputs. The third is to install the YOLO model. So for this demo we are using the YOLO's classification model, and for that we need the Ultralytics toolbox. So if you don't have the Ultralytics toolbox installed, you can install it using this cell over here. We had it installed, so what we just need to do is we just need to import it. Now guys, the YOLO model that we are using is for classification purpose. So given an input image, this model will predict the class of that particular image. The classes that we are interested in this particular demo is whether an image has fire or does not have fire. Those are the two classes. It's a binary classification that we care about, and for this we need to train a model that is able to do this particular classification. And for the model that we are using the YOLO V8 for classification. This is a pre-trained model. It has different kinds of saved weights. There is a YOLO V8 Nano, a small, a medium, and we are using the medium model for doing our experiments today. Now because it's a pre-trained model, it was trained on COCO dataset, but we want to train it on a custom dataset. And to be able to do that, we first need to arrange our dataset, right? So here you can see the structure for the dataset that is required. So you need a train folder in your dataset folder that has images for each class that you're training for. And then you also need a test folder and a validation folder. So let me show you a sample dataset. And for this purpose, we are using Kaggle's Wildfire dataset. There was the Wildfire dataset uploaded on Kaggle, and it has exactly what we were looking for, frames for fire and frames for no fire. It had frames for fire and it had frames for no fire. So this dataset can be downloaded from Kaggle. It's around 10 gigabytes. Once you have this dataset, you can use it for your training and fine-tuning of this YOLO model. Let me show you what this dataset looks like. So as you can see, inside the dataset there is train, test and validation folders. Just to showcase, for example, if we go into the test folder for the fire, you can see the sample images of different aerial views of forests with fire. So these images showcase that there is a fire. And then for the no fire, we can see some of these images where there is no particular fire. The issue with some of these images will be that there may be false positives, because some of the no fire images may have some mist, or for example in this image, or there may be a waterfall because of which there is mist flowing out, and that can cause false positives. For example, in this one, this may just be fog, but a model may classify it as fire, thinking it to be smoke. So these are some complicated cases, and let's see if the model is able to learn all of this. So here is the command for doing the custom training. The idea is basically you could use the Python code based on the Python API to train the model. We over here just use the command line interface. So we use the YOLO command with the task as classification and the mode as training. After that, we just set the base model, which is the YOLO V8 medium classification model, and we give it the data directory. The data directory has been set over here. We set it to the root directory of our dataset, and we tell it the number of epochs and the image size. This image size is whatever image size you want to train at. The lower the image size, the faster the training, the higher, the slower the training. So after all of this training is run, you can see the output over epochs. Then we can validate the model. So this command, instead of setting the mode to training, we set the mode to validation. All right, so once we do this validation, it will save the validation images and we can see the results. Let's take a look at, first of all, the confusion matrix. So this is the confusion matrix that is created by the model when it does validation. So we can see that mostly in the confusion matrix, in most cases, the outputs are pretty much correct. Right, so 140 were fire and they were classified as fire, and they were 140 they were not fired, and they were also classified as no fire. So we have some false positives and false negatives, 7 and 16, which is not as much as the length of the data set. So far the model seems to be working well. Let me just show you some inference images. So this is a validation set. From the validation set, this one on the left are the labels, and on the right we have the predictions. You can see for the most part the model is able to perform correctly on the validation set. There may be a few incorrect predictions. For example, in this one, the model predicts no fire, whereas there is a fire in this image, but this seems like it could have thought that this is a sunrise image, wherein maybe the sun is rising and the sky is turning into that orangey color. But yeah, this was a misprediction. And on the second batch, this is another validation batch, we see for the most part the model is able to predict correctly. I think all the correct predictions are correct in this particular image. So going back to our notebook, now we are going to do the inference on our test data set. So this inference, you can let me show you the output from this inference. Here is our inference results, and you can see that it's able to predict fire for this one, it's predicting fire for this one, which is correct, again predicting fire for this one. So this is what the model is inferring. The next step here is just to export the model. If you want to export it in ONX format or some other format, you can do that. This is not very important for us. Now here we are saying that, you know what, we have trained the model, we have saved the model. Now we will want to load the pre-trained weights. So this is the command, this is the code to load the pre-trained weights and run it on an input video. Now let's look at our basic test that we have done. So for the purpose of this experiment, for this project, I basically downloaded some videos from YouTube. These videos are mostly like aerial videos. For example, this one, it's an aerial video of some fire that has been recorded. I downloaded it from YouTube and ran the model on this particular video. Similarly, I downloaded another video. This one is an aerial video of a forest without fire. This is the input, and then I essentially ran the model on this. And as we've seen before, these were the outputs from the model, right? So here I have added the code for this as well to be able to save the video with the predictions and annotations on top, and it's able to with high confidence predict that there was a fire in the scene. And similarly in this particular scenario, it's able to with a high confidence say that there is no fire, right? So that's what this model is doing. So yeah, this code over here basically just takes the output of the model and creates a video with the annotations on top. So if you're interested, you can use it for this. The code for this, the notebook, is uploaded on our GitHub repository. The link is in the description below. So guys, with such a technology, with using computer vision and AI, the governments, the agencies, they can monitor if a fire breaks out. They can use satellite imagery, they can use some other surveillance cams that are mounted at a high location to predict and raise alarms if they feel, if the model predicts that there is a fire. That way firefighters can get into action at an early stage and contain the fire before it spreads out, before it becomes uncontainable, and we can hopefully avoid towns getting burned, people's homes getting burned. That's it for this video, guys. I hope you liked this video. If you liked it, please hit the like button, subscribe to the channel, and hit the bell icon so you are notified about any new video that we upload. Thanks a lot for tuning in today, and I'll see you in the next video.